welcome you all. In this video lecture, we will be having a concept on indexing in DBMS. So indexing, before getting to the concept, first what's the use of an index in a book? If I want to search a topic, query processing, in the book database system concepts written by syllabus cards, what shall I do? Usually, I just turn the book and end of the page, and the last page I can found the index of a book. So from that index, I can easily found the query processing from the sorted alphabetical order, the text of Q. So I can easily locate the query processing from the page number where we actually the content we're looking for. So the same concept is similar to reflect in DBMS. These are the overview of the indexing and hashing. The first concept, indexing. Actually, indexing is nothing but create a index file. So instead of looking a data row by row, I can directly locate the index file to search a particular data in a record. So this is the search key and pointer. These are the two terms in the index file. So what do you mean by search key? Search key is nothing but a key value used to for searching purpose. In DBMS, we can also find so many key values: primary key, candidate key, super key. But search key is it's not similar to that key values. It is only used for the searching purpose. So the first term in the index file is search key, and the second term, which is pointer, which is used to locate the data values in the record. So index file. So index file, there are two terms used in the index file. The first one is search key and the second one is pointer. Next, there are two variations in the indexing technique. The first one, ordered indices, and the second one, hash indices. The first thing, what do you mean by ordered indices? Okay, write it down. Note it down. Search keys are sorted in sorted order. So it's nothing but ordered indices follow the manner of sequential order. All the records in the index files are put in the sequential order or sorted order. But in hash indices, the search key values are distributed over the buckets. So a term which is used in the hash indices, which is bucket. How can you calculate the value of the bucket? Bucket is nothing but a unit of storage. You can calculate the value of the bucket by using the hash function h. Let me see later on this. Next, order indices. Okay. So there are two variations in order indices. The order indices is nothing but the sequential order of a file, the sequential order of a index file. The first one, primary index, and the second one, secondary index. We can also term as primary indices or secondary indices. Indices is the plural form of the index file. The first one, primary index, which is also called a clustered index. So what do you mean by primary? Primary index means here the search key value is chosen on the basis of the key attribute. For example, key attribute, which means it may be a primary key or it may be a candidate key. So here the search key value is chosen on the basis of the prime attribute. But in secondary index, the key value is chosen on the basis of the non-prime attribute. It may be any other value or column which is the non-prime attribute. Next, let us see the example. This is the instructor relation. This is the example for instructor relation. The first field, which is the identifier. The second one, which is termed as the name. And the third one, department. And the fourth one, which is the salary. So this is the index file. So this is the original record, instructor record. This is the index file for the record, instructor. So here the search key, we have chosen the search key value on the basis of primary key of the table. Here the primary key of the table is nothing but the identifier. So we can choose the the primary key of this table as search key. So it is called, it comes under the category of primary index. Again, one form of primary index which is termed as dense index. So what do you mean by dense? Dense means an index entry appears for every search key value in the file. An index entry is appears for every search key value of the file. That is why it is called dense index file. So using the dense concept, I can easily locate the file by directly follow the pointer. If I want to locate the file Srinivasan data means from this pointer I can easily locate Srinivasan, because here all the entries has been made to the records. So this is the one advantage of dense records. Dense over the next one. Here, this is also comes under the dense index file concept, but here I can choose the search key value on the basis of the key, candidate key attribute of this table, which is department name. So here search key value is nothing but the department name of the instructor table. So the department name here, the department name comes under the category of candidate key. So there are three records comes under the computer science department. So this search key value computer science department only locate the first record. From this record I can easily locate the remaining records by following the pointer. Okay. Next, sparse index, another form of primary index. So keep it in mind. So ordered indices divided into the two variations. The first one, dense index, and the ordered indices divided into the two variations. The first one, which is primary index, and the primary index which is also divided into two variations. The first one dense, so dense over. The second one sparse index. Okay, so sparse index. So what's the difference between dense and sparse? In sparse, an index entry appears only for some of the search key values. Here, actually 12 records are there in the instructor relation. But how many records in the index file? Only 3. So here, the index entry appears only for some of the search key value. Then how can I locate the CADS record? So how can I locate the CADS record? By following the by following the pointer of the 32343 records, I can easily locate the CADS record. So this is the concept. So what's the difference between dense and sparse? In dense, all the records has been made and entered in the index file. But in the sparse, only few records has been made in the entry in the search key. So here search key is lesser compared with the dense record. It is less overhead less maintenance overhead compared with the dense. So this is the advantage of the sparse index file, because less overhead. Okay. This is the similar structure of the sparse index. So this is the index file. This is the data blocks. So this is the data block of 0, which has number of records. This is the data block of 1, which has n number of records. This is the structure of a sparse index file. Okay. Next. So primary index over. So second one, secondary index. So in secondary index, one more levels are added in the secondary index. That is why it is called secondary indices. What's the use of the extra level? This is the example of instructor relation. So the same thing, the first one identifier, name, and the third one department, and the fourth one salary. Then what's the use of the extra level index? Here I can choose the search key value as the salary field. The salary, and keep it in mind, the salary field are repeated. It's not a prime attribute, it's a non-prime attribute. That is why it is called a secondary indices. If I choose a search key value as a non-prime attribute, then I can need, I'm in the need of a extra one level indices to locate the record. For example, this is the salary field. Here the search key values are ordered according with the salary field. Then how can I locate the 40,000? Using the extra level index, I can locate the secondary index. From that index, I can retrieve the data pointer. So this is the secondary indices. So primary indices and secondary indices, these are the two variations in index concept. Then multi-level index. So what's the need of multi-level index? Usually we kept the index file is in the memory, because we actually use the frequently we access the memory. Frequently we access the index file, so usually we kept the index file in the memory or a buffer. But what about if the record, if the index file doesn't fit into the memory, if in the cases of 1000 disk block entries or 1 lakh tuples in the records, in that cases, as database grows, the index files also grows. So we cannot able to fit the index file in the memory. So for such cases, I can prefer the multi-level index. In multi-level index, there are two index files. The first one is outer index and the second one is inner index. Outer index which is similar to the sparse index concept of a primary index. The outer index point to the inner index. From the inner index, we can access the data values. The inner index similar to the primary index concept. Let us see the structure. So this is the multi-level index structure. This is the outer index. The outer index keeps the entry of all the inner index and blocks. The inner index used to locate the data blocks. So this is the multi-level index. Next one, updation. So updation in the form of deletion. Okay. Dense indices. In dense indices, the deletion of search key is similar to file record deletion. So in dense indices, deletion is nothing but simply delete the record. Because in dense indices, every search key has an individual pointer to the data records. But in sparse indices, we need to look up the records where it actually located. Using the index file, first I need to locate the record. If I need to delete the Einstein file, Einstein record means first I need to locate the Einstein record. So for doing this, first I need to follow the pointer of 1010. From this pointer I can follow this Einstein record, then I delete the record. So this is the deletion between the dense indices and sparse indices. And the next level, how can an insertion is performed? Insertion is performed in dense indices. If it is there in dense indices, first I need to look up the space. If there is enough space, then I can easily put the record in that space. If it is not any space is available, means I can use a overflow block. So from that overflow block, in this overflow block, I just feed the new data item. If it is any field, if it is any holes are there, I easily locate the record. If it is not in the cases, I use the overflow block. That overflow block has able to link with the parent block. Okay. So this is the insertion in dense indices. The same thing that we happened in the sparse indices. If it is there, if there is any space already in already in the record, then I can easily put the data into the record. If it is not any space, means then I can create a overflow bucket. In that bucket, I can feed the data. So B plus next concept, B plus tree index files. So why we came for the B plus tree index file? So as we have seen the concept of sequential index file organization. So what's the disadvantages of sequential index file organization is reorganization of data in the case of insertion and deletion. So in the case of insertion and deletion, the overflow buckets is added. So in a particular time, I need to reorganize the data on the basis of the sequential order. This is the main disadvantages of the index sequential file organization. So we came for the concept B plus tree index file. So B plus tree index file is all, which is in the form of balanced tree format, which is in the form of the balanced tree format. So B is nothing but the balanced tree. So the advantages of B plus tree index file is what? Automatically reorganizes itself. So no need for no need for any manual inspection to reorganize the data. It is automatically reorganizes itself, and reorganization of entire file is not required. Okay, so this is the main difference between the sequential file organization and B plus tree index file. And the minor disadvantages of B plus tree insertion file was just overhead on whenever insert and delete such records from the B plus tree index file, it creates its overhead. So just removing that, B plus tree is extensively used. MySQL, the database, used this concept for file organization. Okay. Example. This is the example for B plus tree index file. How I locate the instructor table using the concept of B plus tree index file. This is the structure of B plus tree index file. The first, which is start with the, as usual, which is start with the root node, because B plus tree index file is nothing but follow the tree structure. So every tree structure has able to follow a root. So here this is root, and these are called the internal nodes, and these are the leaf nodes. So the leaf nodes can only able to locate the data records. In the internal nodes have a link with the leaf node. The root node. So the root node at least minimum having 2 children. This is the basic properties of the B plus tree. Next, these are some properties of the B plus tree. The first one, all paths from the root to a leaf are of the same length. All paths from the root to the leaf are of a same length. This is the important property your B plus tree should hold within it. And each internal node that is not a root or a leaf, each internal node, not a root, not a leaf, has between n by 2 and n children. Okay, this is the values we kept in the mind. So the number of nodes in the internal node is between n by 2 and n, and a leaf node has between n minus 1 divided by 2 and n minus 1 values. These are these two things we have to keep it in the mind. Because some practical sessions has been based on these values. Then special cases. If the root is not a leaf, leaf means when I come to enter the first record, it has at least 2 children. If the root is not a leaf means it should acknowledge 2 children. If the root is a leaf means this is the only one record in the B plus tree. So the values range which is between 0 and n minus 1. Next, a typical node structure of a B plus tree. This is the typical node structure of a B plus tree. So the B plus tree node structure having n pointers and n minus 1 key values. Here P can be represent pointers and K can be represent the key values. So n pointers and n minus 1 key values, which is the basic typical structure of a B plus tree. And one important point, the keys are in the sorted order or in the sequential order. This is the main thing. Next, let us have an overview on leaf nodes in the B plus tree, because it is very important in the B plus tree, because from the leaf node itself we can locate the records directly. This is the one form of leaf node, branch. So the leaf node can be used to locate the records from the table. These are some properties of, we can already see the properties of leaf node and the values range between the leaf node in the previous slide. Okay, just skip the slide. Non-leaf nodes in B plus tree. Non-leaf node is in B plus tree is nothing but the internal node. In the internal node also have the same typical node structure. N pointers and n minus 1 k value, n minus 1 key values. Okay, let's skip the structure. Then example of B plus tree. So this is the example of B plus tree with the value of n equal to 6. In previous slides we can see the structure. This is the example of B plus tree with a value of n equal to 4. Okay, so there are 3 levels are used to hold the all the records. In this n equal to 6, only 2 levels is enough to hold all the 12 records of the instructor table. Okay, this is the difference between the n values. Okay, the choosing the n values, which is the crucial part in the B plus tree. And the next one, updates on B plus tree. So updates means insertion and deletion of B plus tree. The first, let us see about insertion concept. Splitting a leaf node. What's the need of splitting a leaf node? Let us see an example. This is the example. Okay, here we had a data item Adams. We need to put the item or insert the item in the B plus tree. Okay. So this diagram, which is the already we hold the diagram B plus tree, 12 instructor relation tables. In this I can insert an Adams. So in this tree I'm going to insert an Adams record. So first I need to search any space in the leaf node. So I just overlook on this leaf node. If it is there any space, no. So no for insert the Adams. So for such cases we split the node into 2. So I just split the node into 2. So Adams and Brand comes with the one node, and Califrey and Krieger comes into the another node. So this leaf node is split into 2. So in this case, I should add one more key value in the internal nodes. So the Califrey, which acts as a key value in the internal node. Is it there any space it here? Yes. Is it already spaced here? So just I add Califrey here. This is the one of the insertion of Adams in the B plus tree. And the next I'm going to insert one more term, Lamport. Okay. The same thing, I just look up on the B plus tree whether it has any space. Whether it has any space, no. I can insert the Lamport after K. Is there any space it here? No. Just I split the node into 2. So Lamport and Kim. Lamport and Kim comes into the one node, and gold and hats comes into the another node. So I split the node, I split this leaf node into 2. So I need to add one more search key. So one more search key, Kim. Is it there any space to add Kim in this internal node? No, it is nothing possible to add Kim in this Srinivasan. So I add one more. So I would add one more node. So in that node I just add the Kim. So this is the insertion of Lamport. Okay, so the demonstration of how to insert Lamport. So this is the overview of B plus tree file organization. So index file degradation problems is solved by the B plus tree indices. This is the important concept. And some more concept, the degradation problem is solved by B plus tree. And it is automatically reorganizes itself, but in the index file organization we have to manually did some reorganization concept after a particular time period, but B plus tree reorganizes itself. That's the difference between index sequential file concept and B plus tree file concept. Okay. The next concept, B tree index file. This is one more variation of the B plus tree. So B means balanced tree. One important point I should remember in the B plus tree, here the key values are repeated. So redundant data are placed in the B plus tree, which means B plus tree allows redundancy, but B tree doesn't allow any redundancy. This is the difference between B plus tree and B tree. Note it down. Califrey. So these are the redundant data. So repeated. So Einstein, the record Einstein repeated. Such records are repeated in the B plus tree. Let us have an overview on B tree. This is the difference between the B tree and B plus tree. No any records are repeated. So B tree has been made a unique record. So it doesn't allow any redundancy. And one more difference between B tree and B plus tree, which is the a typical node structure. Okay, so it allows both, and this is the first A. So, okay, A, the figure A represent the node structure of a leaf node, which is typically equivalent to the B plus tree. This is B. The figure B represent the node structure of the internal node. So one more term is added. B. B is nothing but the bucket. So what's the use of the bucket? The bucket used to hold the record of the Einstein. So hats means hats have its own bucket to hold the record of the hats. So sync this key value has one more bucket to hold its record value sync. Okay, so this is the difference between B tree and B plus tree, and so an insertion and compare with the insertion and deletion, B plus tree adds some additional overhead when maintaining the insert and delete the records. Okay, so compare with the B plus tree, compare with the B tree. B plus tree more suitable than more suitable for many applications because less overhead. This is the concept. Just example, multiple key access. Okay, this is the example. Select ID from Instructor where department name equal to finance and salary equal to 80,000. Okay, this is our query. Okay, how can I choose an index file? So, okay, first approach, I can choose an index file based on the search key, department name. Okay, this is one way of approach. So I can easily locate finance and use some predicate to calculate the salary field. And another one approach, I can choose the salary field as the search key of the index file. So I can easily locate the search key of, I can easily locate the salary field and use some predicate to access the finance. This is another one approach. And one more approach, I can use both department name and salary. I can use both search key values as a search key of the index file. So I can easily directly locate the records directly, but a little overhead, but little conflict. If the little conflict means if the balance is so instead of using salary, if I change balance equal to 80,000 means for this query it cannot be able to apply for this query. So just avoid to choose the combination of the search key. So this is the things. So indexing concept is over. So let us see a hashing concept in the next lectures.